Okay, so we're going to be talking about adding ethical reasoning problems to Calculus 1. So first, just briefly, why do we want to do this? So we got involved with this over the last summer as part of the NSF grant, Normalizing Ethical Reasoning in Mathematics as a Foundation for Ethical STEM. And the idea here is that ethical reasoning is usually taught late in undergraduate or in graduate school if it's taught at all. So I don't think I ever had any ethics training in my training. But we really want it to be seen as not just something that you stick on at the end, but something that is an integral part of using math. That anytime you're using math, you should be thinking about how that's being applied. And so starting it early will help tie those two together. And then even the students who don't go on to math, they're still going to go on, a lot of them will go into STEM fields where they'll have similar ethical codes to use, or they'll be using math in those fields. Also, this was kind of going along with the development of a code of ethics for mathematics, but having an ethical code is not useful if students are never taught how to use it. So that's part of the idea of it as well. How we define ethical reasoning is a process of reasoning about ethical issues that involves the following steps. So these are things that we could focus on, and then the ones that we are really focused on when we were writing problems were these three. So identifying and quantifying your prerequisite knowledge, identifying and recognizing the ethical issue, and then identifying and evaluating alternative actions. So we didn't really talk about frameworks a lot because we didn't want to get too much into like being a philosophy class, ethics class. We mostly just wanted them to recognize that, that there is an ethical issue, and that what knowledge they might need to decide that issue, and then to think about the alternative actions, even if they don't necessarily have enough information to make a decision in that moment.
So we decided to focus on Calc 1, mostly because we were both planning to teach it in the fall. And we wanted to just find a way to integrate the ethical reasoning into our course, instead of adding like extra projects or having it like a separate like ethics day or something like that. So we created a set of problems with basically the same structure. There'd be a part where it's just calculation or computation, like find the derivative, interpretation, like what does this mean in the context of this problem? And then we would add some sort of ethical question. So the problems all had to do with, something in the real world that, there could be, decisions that you had to make that could potentially be problematic or not. Depending on the problem, we had different sort of frameworks for the ethical questions. Sometimes it was just like a cost benefit analysis. Sometimes it was trying to decide if a proposed action was ethical. And sometimes it was finding items in the mathematical guidelines or proto guidelines to justify whatever decisions they might want to make. So the proto guidelines are being developed by the PIs of this NSF grant. It's Catherine Buell, Victor Piercy, and Rochelle Trachtenberg. And they have been working for several years building up this set of guidelines, because there isn't a code of ethics for mathematical practitioners. So what we have here is just 4 of them. I think there's 40 total at the moment. But they're all basically the same sort of format, where the ethical mathematics practitioner does something, right? So it should be forthright about any circumstances that might lead to real or perceived conflicts of interest. Again, there's 40 of them. So when we did provide these to our students, we would pick, much smaller subsets because there's a lot of reading involved. So we ended up making problems for, I think it's ended up being 12 or 13 different topics here. Neither of us ended up using all of them in our courses, but our goal was to make a problem for each of the major topics. We basically just looked at our syllabi, wrote down every section we were going to cover, and then said, okay, we'll make a problem for each of these. And And I think next we're going to talk about how we actually implemented these.
Yeah, so in my class, it was 19 students, mostly freshmen, sophomores, well, 12 freshmen, sophomores, 7 juniors, seniors. We had a lot of different majors, so there's not a lot of just math majors. By the way, I teach at a small liberal arts college, so there's about 1,000 students total. So we don't have a lot of math majors. They were mostly engineering, biochemistry, and then undeclared, with a few other areas like business and art. It's a Monday, Wednesday, Friday, 50-minute class. The textbook we use is Early Transcendentals. And the normal structure of it is just that we have a weekly online homework through the online homework system. So the way that I decided to implement these problems was as math and consequences days, I called it, because I believe in strong branding. But we mostly did that on Fridays. So we had, out of the 15 weeks, I scheduled exams on Fridays, and then there was like 1 or 2 that Fridays were days off. And then every other Friday was a math and consequences day. So they kind of knew it was coming. I put them in groups, and they worked on the problems in their groups. It was mostly graded for participation. So I did like assign it points just because I wanted to make sure that they were motivated to actually try to get it done. But I was like, always going, like, they could ask questions and everything. It wasn't like a quiz. So I went around and offered advice. And so it was mostly just as long as they, tried put some effort into it, then they got full credit for that. And then the worksheets, you'll see some of the problems. We'll show some of the problems, but it was still in large part doing math for most of the class. And then the ethical components were kind of smaller parts that were integrated in there, as we will see.
So my class, I'm also at a small liberal arts college. So I had only had 13 students. They were mostly freshmen, a couple upperclassmen. Students in my calculus classes are usually physics and chemistry majors, and people who are taking it because they're applying for grad schools that require calculus. We meet Monday, Wednesday, Friday for 80 minutes. But only for 12 weeks. We have a 12-week term. And the textbook I used was Active Calculus by Matt Belkins, which is an open access. And I always assign online practice problems for sort of pseudo extra credit, and then a weekly written homework that usually involves a lot of explaining what and why they're doing things, as well as just, regular computation stuff. The way that I implemented the problems, I also did the interactivity on the first and second days. My plan was basically just to throw these problems into our regular sort of like working on practicing techniques, in class. Due to lots of time constraints and things taking longer, which we'll talk about shortly, I ended up turning it into sort of a combination of in-class and homework problems. So we might start something in class, and then I'd have like a follow-up homework problem, or vice versa. But then we try to talk about the ethics situations later on. So we're going to go through a couple of problems that we put together. So the first one that we did was on average rate of change. I was actually inspired to write this by a podcast that was talking about how do we actually determine if we're in a recession, and it depends on basically the average rate of change, but the time interval, how you choose your time interval changes whether or not we're in a recession. So I found data on the Consumer Price Index for every month since January 2017. We gave the students a big table with that. They were asked to sort of just practice average rate of change calculations from there, and then specifically to find different time intervals to make the change in the Consumer Price Index as alarming as possible or as not alarming as possible. To be like, oh, it's increased, so much in this time period. And then finally, the basic, ethics question was, if you were trying to advise somebody about how the CPI is changing, would it be your responsibility to present both viewpoints, meaning like the alarming version and the not alarming version? And then we asked students to sort of justify their answers to that question. And then on the next slide, we have follow-up question that I assigned after we had this discussion in class. So you can see the table that has sort of, all the data that we gave them. And then I asked them, we had in class done a lot of work with, manipulating what kind of answers we could get. And I asked them to think about, what would be a better or more truthful way to talk about how prices are changing. My goal was to get them to think about more like an instantaneous rate of change thing, because we had been talking about taking smaller intervals and that kind of thing. Nobody made that connection, which was unfortunate. Next time I do this, I'll probably try to make that a little bit more, put a little bit more focus on that. But they did have some interesting ideas and some not so interesting ideas. So some of the responses to this was the first of the problems that we wrote that I gave in my class. I think Juliana also.
Yeah.
The main thing that I learned from this problem was that they really didn't understand how to interpret average rate of change outside of the context of velocity. And so there was a big, a really long conversation about the difference between change, like absolute change, and rate of change. The other thing is, because I don't think the word ethical showed up anywhere in that question. They didn't realize that it was actually that there was an ethical decision or something that needed to be thought about. So then in future questions, both of us ended up adding the guidelines to most of our questions and asking students to look at those and reference them. And then we also both realized that we needed more time than we thought to actually talk about these problems.
Yeah, so here's another example. So this is one that was kind of a challenge topic to write for, because it's continuity, which is not usually having a lot of applied situations to go with it. But we came up with this example where we have two neighborhoods that are during a storm, and what percentage of the houses in the neighborhood have power. And so we asked, first of all, just questions like, what's the limit from the left at 1? What's the limit from the right at 1? And that alone kind of took a little while, because they had only recently learned it and they hadn't done the homework on it yet. So just getting practice with the limits, where are all the discontinuities? Interpretation question was what do the discontinuities mean in this graph? And that was a bit of a struggle, in that I got a lot of answers the discontinuity at 1 means that the percentage went from 100% to 10%. And I was kind of looking for more it's because lots of houses lose power at the same time, and it's not a gradual amount, not a gradual decrease of how many have power. And then we had a few questions at 2 hours in, which neighborhood should be prioritized for needing power, and then at 5 hours, which neighborhood should be prioritized for needing power, for power repairs first. And we were sort of thinking of that as being the ethical question at first, but then when we had someone look over our problems, we saw that there wasn't really that wasn't really a mathematical ethical question per se. It was an interpretation of the graph, and they could have arguments either way, but it wasn't sort of using any of the mathematical guidelines. And so we added in, so here's the version that I used last semester, was to try to add in something that would get at the discrimination part of the guideline to avoid discrimination, is to include a housing value in the two neighborhoods, that one neighborhood has a higher housing value, and asking, does that affect your choices? However, that obviously, didn't lead to great discussion, because they pretty much all just said, no, that should not have any effect on the choices that we already made. So then for this semester, I'm teaching calculus again. So I rewrote that part, and instead I wrote it this way, that there are several factors power companies can take into account. Which of the following factors would be ethical to add to the model above to assist decision making? And then I gave them 3: the location of critical facilities, the average amount in local property taxes that each neighborhood pays, and the distance from each neighborhood to the nearest major power transmission line. So then there was more discussion because they sort of went through the list and thought about them each. And everyone agreed that, this first one should be an important factor. Most of them said that the second one should not be a factor. And then the third one, there was actually some different answers of like, that it would be like unfair to prioritize those who are close to the main power transition line, which I thought was interesting. But they just did this on Friday, so we haven't gone over it yet. We'll talk about it on Monday. I also gave them a sort of shortened list of the ethical guidelines to reference for this as well.
So the last problem we're going to talk about, I actually adapted this from a problem in the Hughes, Hallett, and Gleason calculus book that I actually used in high school because I had a copy of it laying around. So basically, there's a situation where an industry is being charged with dumping an unacceptable level of toxic pollutants in a lake. The two graphs that you can see here it was basically two parts of the problem, saying like if this engineering firm takes measurements of the rate at which pollutants are being discharged, if they produce the graph on the left, it would sort of describe what's happening. And if they produce the graph on the right, sort of describe what's happening. So the way that we edited this was to ask, well, suppose that you work for this engineering firm and both the industry and the EPA come up to you and say, hey, like, could you be our specialist, represent us in court? And then we asked students to sort of decide which of the two groups for each graph, each of those situations, which of the two groups would they choose to work for and why? And to justify their decision, I gave them a subset of the ethical guidelines to reference so that would help them decide, which one was, the more ethical decision. And then also to ask them, we also asked them to make a mathematical argument to support whichever group they ended up, deciding to work for. The way that this played out was not really what I expected. When I gave them, and I think this was the first problem in which I had given them the guidelines to reference, most of the students applied the guidelines to the industry and not to themselves. So they weren't interpreting them as guidelines for them as a mathematical practitioner. So for example, one of the guidelines says that the ethical mathematical practitioner is informed about applicable laws, policies, rules, and guidelines. Several students said, well, the industry is clearly not informed about these things, and so it's not ethical for us. And so they're not being ethical. So I will not choose to represent them. Some better, use of the guidelines with students saw the one that says that, they should minimize the possibility of harming others, that, they could make a reasonable justification for representing the EPA. But even then, they didn't really get any of the sort of mathematical content involved here. Most of them basically just said, pollution is bad. We shouldn't harm people. Pollution harms people. So we're only going to work for the EPA, regardless of the two situations, and couldn't think of most students could not think of any reason to ever possibly consult for the industry. But it kind of, they sort of ignored the math, they ignored the guidelines, and they just said pollution is bad, can't work for the industry. So, not really what I wanted.
Yeah. So the results in my class was we did 8 worksheets, but they did end up being usually longer than what we had time for in class. So as Kathy sort of said early on, sometimes there were mathematical misunderstandings that came out during the math calculation and interpretation parts of the worksheets. And so they didn't get to the ethical part as much. So I started putting 2 problems on a worksheet, knowing that they probably wouldn't finish the second problem, but at least they would all get all the way through the first problem. We also didn't do much whole class discussion because personally, I don't have experience leading whole class discussion. So I kind of just let them discuss about it in their groups. And then I would sometimes like collect their answers afterwards and sort of share like, here's, what some of your classmates thought. But I haven't quite got to the level of leading class discussions.
I only managed to get through 5 of the scenarios. One of them was purely on homework. Most of them were sort of a combination of the homework and the in-class. Like Juliana, the discussion, both of the ethics part and the math part usually took a lot longer than I expected. I think moving some of them to the homework was helpful because it gave students time to work on, again, either the mathematical part or the ethics part. It gave them more time to think about their responses and come up with better answers for themselves. And then I could see what everybody had written and sort of bring out the common themes. As I mentioned before, it really helped me realize how much of the math they still weren't quite understanding, even if they could answer all of the other sort of interpretation questions that I typically ask pretty well. And the guidelines were very important to get them to actually think about like how to justify things, even though it didn't always work out. Again, like pollution is bad.
So we asked for some student feedback at the end. I had 16 students give feedback. It was not anonymous, so I guess take it with a grain of salt. But I did tell them that I wanted both what they liked and what they disliked about it. And most of the students said it was positive. They liked that they felt like real world problems, that they were longer, sort of more of a project, I guess. The fact that we spent a whole class period like working on 1 or maybe 2 problems and they had multiple parts. And so they kind of had a chance to like really get into a problem, and then having that part where the ethics part where you're looking at the consequences of these decisions that you're making, I think made it feel more like real world problems, which they liked. So some of them said, some of the comments helped me connect what I was learning with class and how it was used in the outside world. Helped me see a different side of math, one that could be ethically wrong, even if the numbers were right. That was something we tried to get to with the ethics question, like especially in optimization, that if you just because you've optimized for it and you've got an answer with your optimization doesn't mean you were optimizing for the right thing. And how calculus can apply to real world issues. I had a few suggestions, so they agreed with me that sometimes the time was too much or there wasn't enough time to really get into thinking about the questions. One of the students suggested that it would be better for upperclassmen instead of freshmen. So I may need to justify a little bit more why I feel it is important to include in an early level class. And then some of the scenarios they thought might not apply very much to their lives. Like, I don't know, maybe they're not going to be working on the power grid management company or something. So maybe finding, that's might be something we could improve, is to find more applicable situations.
My students had a similar sort of takeaway. I did get a lot of comments about, like math is not just about the computation, and a couple good quotes we're going to talk about. One student that I don't have a quote from basically said that it was silly to spend so much time in class, like to be talking about it through class. We should have just had one conversation because everybody already knows the ethical answer anyway, was basically the gist of their argument. And I think that goes along with the sort of like, oh, well, pollution is bad, so we can't, like we know the ethical answer is to never represent the industry because pollution is bad. And I'm hoping, as I do this more often, to sort of get students thinking a little bit more about the nuances in this kind of thing. Some good quotes. We're running out of time, so if you want to just skip to the next one, the last one.
Yeah.
I thought this was very interesting. The student said that they didn't realize the questions involved ethics because no one I know of has ever been raised to think about math as anything but objective numbers or letters on a page that mean nothing. I was like, well, I hope that they don't really think that the numbers mean nothing. Even before embarking on this project, I always ask students to like explain what the numbers meant. But at least through doing this semester, I got, several students thinking like, oh, well, okay, not only do we need to think about what the numbers mean in terms of like what she's asking me in calc class homework, but also like they're not as objective as they seem.
Yeah, and so we're about out of time, but just so our ideas for improvement, maybe give students some more background information. That was definitely a thing where sometimes they just didn't know like anything. I mean, they're freshmen, a lot of them are freshmen. They're just not familiar with a lot of topics. Maybe a simplified version of the ethical guidelines. We're also working on, I'm using these materials again, so I'm kind of giving them another round of edits and improvements. And Kathy's teaching Calculus 2 right now, so she's working on some more of a full semester project for that. And we're also hoping to write some just regular Calculus 2 problems in the same vein as our Calculus 1 problems. And yeah, so any questions?
So thanks very much. This is a really interesting talk. I'm wondering if there should be some sessions, maybe at the next expo, where people who are interested in bringing ethics into mathematics courses would just meet and maybe, have 5 or 10-minute presentations with very specific examples of the kinds of things they've done. So those of us who are interested in it could kind of exchange our best ideas.
I think that would be great. I know that as part of the NSF grant, in the next 2 years, there will be a big push on disseminating what we've done. And more than just in us giving talks. So I think they're probably looking at doing that kind of thing sort of anywhere we can.
I'm actually familiar with that NSF grant. Could you talk a little bit about that maybe?
I don't know how much I can talk about it intelligently. So yeah, so the PIs are Catherine Buell, she's at Fitchburg, I think, Victor Piercy at, shoot, I don't remember. It's at Ferris State, yeah.
Yeah.
Rochelle Trachtenberg, she's at Georgetown University. So they are the ones who have been developing the ethical guidelines, and they got this NSF grant. They put out a call for applications last year, and 16 of us, and there are a few other talks even going on here at this expo from people in this project. So the 16 of us, we did a 3-day workshop in the summer, sort of just brainstorming and beginning to develop these ideas. That's where Juliana and I came up with, like, I think 2 of the questions that we ended up using. And then, so lots of people have done lots of different things. Some are doing like their senior capstone kind of projects. Obviously we focused on Calc 1. And then, yeah, through the next couple of years, this was sort of the pilot year, people writing their problems and trying them in their own classes. And then the next couple of years will be sort of disseminating that either through talks, also talking to like industry and other partners and that kind of thing.
Cool, thank you.
Yeah, definitely getting, people with different experience as well, because I have never actually worked as a consultant. So, but, trying to write these problems requires, a little bit of research and imagination from me, but, having people who maybe have spent some time and like actually run into ethical issues, it'd be great to have feedback from them.
I think it's a very, I'm gonna say, yeah, I think it's a very interesting topic. I missed some of your talk, but I see that you use 2 different words. One you used consequences and one you used ethics. Could you explain how come you separate those 2 things? I mean, I think it's a good idea to separate them, but could you talk about that for a minute or 2?
Yeah, so the consequences I mostly just used as the title of like the worksheets. So they're called here I have the one that they did, so they're kind of labeled like that, the math and consequences worksheets. And I kind of think that I tell them that it's ethical reasoning as well. I do use that word, but I feel like that it's somewhat less scary to say consequences, because then it doesn't sound so philosophical or anything. It's just like, if you are using math in the real world, like, things are gonna result from that, right? There are going to be consequences, and so you should be thinking about that and cognizant of that when you're doing the math. So that way, it's, I guess, for me, it seemed like a friendlier thing than calling it like ethical reasoning worksheets or something.
I agree 100% with you, because like when I hear ethics, I feel it's like someone is telling me what I should do. Whereas consequence is almost like an engineering problem, is that if you build these are going to be the impacted communities, these are the various stakeholders and so on and so forth. And then you can decide, I don't know, where you want to put your money. Whereas ethics, it seems very much like you can just argue all day long and you're not going to get anywhere on it, because ultimately there's, it's very, very subjective. So I think it's good the way you broke it into two concepts.
Yeah, any other questions? Oh, we have a chat. Yeah, see, so you would probably be a good person to write more realistic scenarios.
More than happy to help.
Yeah.
In your discussions, did you come up with any way to make a decision on something other than I just, feel, I feel this is more important than that?
Well, that's why we kind of had the guidelines, so at least they could say for some things like the problem where the first problem we showed with the average rate of change, where like a lawmaker asks you, one way we phrased it was a lawmaker asks you to find evidence that inflation is increasing. And so they could look at the guidelines, and one of them is like not to have what is it, how's it phrased, like the answer decided in advance.
Yeah.
Exactly.
something
Yeah,
like
that's yes, it's like cherry picking. It's not good.
Right.
Yeah, so that they could reference that and say, well, this would be an example of looking for an answer in advance, and so or having decided the answer in advance, so that would be an unethical thing to do.
Yeah, although actually in my college, they almost even have a course in the opposite direction. It's called like advocacy something or other, where advocacy research, where you start out with what the solution should be, and then you find the research to sort of back it up, which I kind of think is in and of itself is kind of a little bit unethical. In other words, if you
Yeah.
already know where you're going, it's kind of biased
Right.
everything. But that's where the direction that things are moving in. That's what people want to do, because I guess it's more effective. In other words, if you're going to get hired to do something, the person hiring you doesn't really want to hear you tell them, "Oh, it's not such a good idea." They want to be like, "How can I do this idea?" Yeah.
Right.
Interesting.
Yeah.
Thanks very much.
Right.
This was a very interesting talk.
Yeah. Great talk. Thank you so much.
Thanks for
Yeah,
coming.
thank you. All right. See you.